So today we will cover Hyperband for hyperparameter tuning. And first of all, sorry for the crappy audio. I've ordered a Zoom H4n Pro Black, and when this arrives I'll definitely have better audio. So I will feed this into the audio in of my camera and will apply some dynamic pre-processing and so on, compressors and so on. So we will have better audio and also a backup track. Okay, so Hyperband. In the last video I've covered Bayesian optimization for hyperparameter tuning, and I just need to add one thing there. So it was a little didactic mistake, which I did because first of all I introduced Bayesian statistics and conditional probabilities, and later then I just directly moved over to the Gaussian process model training, and I didn't really explain how those two things relate to each other. So the thing is that the Gaussian process is actually a conditional probability distribution. So what you actually do is you have the probability of a certain outcome, a certain loss value or certain quality of your model given a conditional probability, and the condition where you lock in this probability function is basically the actual chosen hyperparameter. So given a specific point or specific hyperparameter set, what is your expected, let's say, quality of the model? So that's where this Bayesian statistics comes into play. Okay, so now Hyperband. Hyperband is actually taking the idea of random or Monte Carlo optimization. So we are actually going again a step back, and the authors claim that it's actually one order of magnitude faster than Bayesian optimization. So there are three types of Bayesian optimization commonly used. I will cover that also later. But now let's have a look at Hyperband. So Hyperband is using an algorithm which is called successive halving, and I'll just explain that first. Okay, so the idea is in random or Monte Carlo search, you just take a set of random points in that hyperparameter hyperspace and evaluate. You train the model with that hyperparameter set, and then you see how good it performs. The problem here is you always train until the end, so you are wasting a lot of resources for poorly performing choices of hyperparameters. And the idea here is to introduce early stopping. So what actually successive halving is doing, it applies a budget of resources to each training, so to each point in the hyperparameter space you are evaluating, and once this budget is used up, it stops. So it will basically stop poor performing trainings very early, and will then just take the, for example, top 50% of the best performing configurations. So this is a parameter you can tweak. You can take 50% or 30% or whatever. So that's successive halving. And where then Hyperband comes into play is that in successive halving you basically need to adjust the amount of survivors, no? And also the budget. And what then Hyperband does, it has an outer loop, so it calls successive halving multiple times, but with different configurations for budget and the amount of survivors and resources. So the idea is Hyperband is, in a nutshell, nothing else than grid search over successive halving executions. So yeah, okay, and yeah, let's see how that performs. So I need to create some more videos. I will dive into more detail for the Bayesian optimization algorithms, and obviously I need to double check whether Hyperband really performs one order of magnitude better than Bayesian optimization. And I think it really depends on the neural network and the data, but let's see. All the best. See you. Bye.